Hi, welcome back. We're gonna expand on what we covered earlier on list. Now we're gonna go into covering some of the really useful methods that comes with list. Okay, so let's start with append. This is something that we are familiar with because we've seen it before. You have the list. I call it list here. Dot append, meaning adding a value. Okay, basically add an item to the end of the list. Okay, it is equivalent to this. So basically you have A is the list of 1, 2, 3. When you append 4, you basically have 4 added to the end of the list. What about extend? Extend the list by appending all the items from the iterable. Okay, so so you have A is an iterable. So what you have here is that you have B is also a list. When you have extend, basically what you have is that you extended B with A. Alright, so that's really the basic idea here. Insert is insert an item at a given position. The first argument is the index of the element, so meaning where do we want to insert this, before which to insert. So you have a.insert 0 inserts at the front of the list, and a.insert length of A is equivalent to adding it or inserting it to the end, which is the same as append. So we have B, and then we have insert at the index number 3, which is 0, 1, 2, 3, 1007. So let's have a look. So notice that at position number 3, it insert 1007 and push the rest to the back. So let's continue on. Remove here is remove the first item from the list whose value is x. So in this case, because we specify x as the value, all right, what you will get is that it will remove that value, but it will only remove the first item. If you have 4 of the same observations, it will only remove the first one. But if it cannot find that value in the actual list itself, you will actually get an error. So let's print B. We have 1 in here, so 1 will be removed. Now what happens if we ask it to remove 7? And you're going to get an error basically telling you, hey, X is not in the list. All right. Pop is another method whereby it removes the item at a given position in the list and return it. If no index is specified, a.pop removes and returns the last item in the list. Okay. The square bracket around the I in the method signature denote that the parameter is optional, not that you should type square bracket at that position. You should see notation frequently in the Python library reference. So similar to remove, except remove a value if it's in the list. Pop here is actually pointing to a position. So you have B here, popping 2, meaning we want to remove 1007. Now it's gone. Okay, it's gone from the list B. And if it's clear, basically remove all items from the list. Okay, so it's equivalent to delete A with the column. A it looks like this, B looks like this. Okay, and if we C is equal to A, D is equal to a copy of B. Let's have a look at C again. If we clear C, C should be nothing, empty list. What about A? A is also an empty list. It is at this point that I do want to actually highlight something. This whole exercise here is to highlight some very important point about copying. This is not really copying here. This is actually copy by reference. Okay, so what it has is actually it's pointing it to a specific location. Shallow copy. Okay, copy by reference basically means that C is not copying the value of A. C is actually, when you do this assignment here, it's just actually C is actually pointing to where A is stored. So when you actually clear C, you actually clear A at the same time as well. Right, so let's look at D. When we actually clear D, D should be empty and B will still stay the same, unchanged, because we did a shallow copy here. So this one is actually copying the value rather than copy by reference. Okay, so let's move on to index. List.index, you have the index, you have the start, you have the end here. Return a zero-base index in the list of the first item whose value is x. So let's just say we have b here, right? We're trying to find what the index number that has the value 3, and what you get is actually 0, 1, 2, 3. Okay, so it tells you the index, okay, the location. All right, what about count? Count returns the number of times x appear in the list. Okay, so let's create a long list of B, and we want to count how many 11 is in B, and what you have here is 1 here and 1 here. That gives you 2. And sorting is, as the name suggests, sorting it in either ascending or descending order depending on how you define it. So let's print B first, sort, and print B again. Notice that it's from ascending order. If we want to reverse it, that becomes descending order. And reverse basically is reversing the order, and now is in the ascending order. Copy, dot copy here basically return a shallow copy of the list. We talked about that slightly earlier. So let's look at this. You have the base example, base underscore example, which is what I call it, and what you have is that it's a list of a list. Okay, list within a list. You have 7 and 5 is actually a list, right? And then you have the 3, 4, 6 is it's a list item on its own. Okay, so so what we want to do is that we are doing an assignment. So base assignment looks like this. Okay, so this is not really copying, it's actually assigning, so it's pointing to the same location. So when I actually change index 1 to 0.4, the base example will also change. Note the copy by assignment. It is pointing to the same location. When you change the copy, you are changing the original. Okay, so that's what we actually mentioned earlier, much earlier, copy by reference. Okay, so that's that. It's the same here, copy by, actually I should call it copy by assignment. Let's just maintain consistent terminology here. Okay, let's come back down. All right, here's a second example, which is a shallow copy. Okay, so assignment, let's go back to assignment first. Assignment statement in Python do not copy objects. They merely create the bindings between the target and an object. Now, for collections that are mutable or contain mutable items, a copy is sometimes needed, so one can change one copy without changing the other, which is the case of list. So here we have a shallow copy. Okay, so if I change the index, the value of index 1 to 3991, the copy will change, but the original copy will not. Okay, note that due to shallow copy, the original data was not affected. This is still a problem though. The problem arises when you try to change the list. The list is within the list itself. If I actually change this number here to 999.99, the base example will still be changed as well. So in this situation, we will need to perform deep copy. So from copy, import deep copy, and we perform this deep copy of the base example and save it to this value, which we call base underscore deep copy. And when we actually do change the second, the index 1, the base doesn't change. And when we actually do change the number within the list, it doesn't change as well. Okay, I hope that has been useful. We've covered a lot of some of the features that comes with list. There's still a little bit more to go through. For now, let's stop here. We'll come back to that a little later.